I am having a problem with my lightsaber blade. So let me demonstrate this. Do you see that? It's a little bit blue. The lightsaber is displaying the white color right now, but this section here looks a little blue. Now it's red. This section is pretty dark. Here's a yellow. This little section looks a bit green. What's happened here, the red LED and the RGB LED that's right here has, for whatever reason, failed. So I need to take this apart and figure out why it failed and how to fix it. First thing I want to do, though, is I want to mark what LED it is. Stick it right on the spot where that pixel is. I'm going to call them pixels. I can't help myself. So that way, when I take it apart, I can line the clear blade cover up to the thing and figure out where the actual pixel is. Taking the blade apart is very simple. I've shown this in many videos. You have 3 screws here, Phillips head screws. Just unscrew them. This next step may or may not be a little difficult. You need to separate the 2 halves of this black plastic here, and it might just fall right apart, but more than likely you're going to have to sort of dig your fingernails or a spudger or something into that seam there and sort of force it apart. And there's one half of it gone. This little piece of metal there that's used to align the blade when you plug it in. Don't forget to grab that and put that off to the side. And then there's a second half here that will also come off. Again, it might be really stuck in place and you're going to have to use a little force to get it off. Another piece of the alignment. And now the outer covering here will just slide right off. It also might take the this foam with it. You don't really need the foam, so I'm going to keep the foam in the tube. I'm going to try to. So the next thing I want to do is I want to try and locate the LED in question. So I'm going to line the blade cover, the blade outer layer, whatever you want to call it, here. Line it up at this end. And then I want to take the blade, move it around like this until I find that mark. And there's the mark that I left with the tape. So either this or this, one of these LEDs here, probably that one, is going to be the problem. So I am going to mark that with more tape. Some of these LEDs are different. Look at that LED right there. It's much more cloudy than these other LEDs. That is interesting. I've put the black tape over the LED that's above what I think is the broken LED. My interest is a little piqued here because I've got this cloudy LED here and I've got another cloudy LED here. This is stock. This is how it came. That's interesting. So I would like to test the LEDs and see if I can identify the one that's broken. Which means I need to use my multimeter here, which has a diode testing mode. And what diode mode does is it's going to put voltage across my leads here, positive and negative, and you can use that to power up an LED. And this thing is going to measure the forward voltage of the LED. But what I'm more interested in is the fact that it's going to turn the LED on. Another thing I should mention real quick is these LEDs are what are known as a common anode LEDs. So diodes have a cathode, which is the negative side, and an anode, which is the positive side. What that means, common anode, it means that power comes in through one pin into these RGB LEDs, and then it exits through one of the 3 colors. So the positive side is the common anode pin. The negative side is going to be the color for that you're testing. There's a nice little hint here as to what pin does what. You'll notice that there are resistors on either side of these pins here. There's one resistor here, and there's 2 more over here. Each resistor is used to limit the current, in other words, to control the brightness going through the different colors of the RGB LED. There's one resistor on this side, there's two on that side. So the farthest pin over here is going to that resistor. These two pins over here, the closest two pins to these resistors, go to these two resistors, which means that this fourth pin that hasn't been covered by a resistor, that is your anode, your common anode. So that is where the positive of your multimeter should go, and then the negative can go to one of those pins to test. Oh, there we go. Can you see the blue lighting up there? And then you can see the green lighting up there in the LED. That is how. If I come over here, you can see the red lighting up. That is how you can test individual LEDs. But we have an extra feature here, because all of the common anodes in the first bank are all connected to one pin down at this little connecting spot here. And then all the blue pins are connected to another, all the reds of all the LEDs in the blade go to another, so on and so forth. So you can actually test a whole range of LEDs down here through just these pins up here. There we go, there are all the blue LEDs lighting up. And you can see where the first bank ends. So now I've got to arrange this in such a way that I can show you me testing the second bank. And we know, again, that it's going to be an LED around here somewhere. It should hopefully be that one. And there we see all the blues lighting up. Great. There are all the greens. Alright, now comes the red. And do you see that? Do you see that their red LEDs are all lit up? Except for that one just below where the black electrical tape is. Confirmation that we have a goofy red lead on that LED. Excellent. The problematic LED has been identified. It has been marked with some black electrical tape. Now the next step is to determine if the problem is in the LED itself, or if it's just the solder connection might need a little help. So, what I'm going to do is I'm going to bring my probe for my multimeter directly to the pin itself, not the solder, and try to light up that red LED. And I'm lighting up all the LEDs around it, but not that one. Which is telling me that the problem is the LED itself is bad. That LED has to be removed and replaced. So how are we going to do that? A fine question. So the first thing I need to do is I need to remove that LED. So my plan is really just to flood those 4 pins with solder so they're all connected together, and then just pluck it off with some tweezers because all the leads will have molten solder. So that's the theory. Because the way this PCB is designed, the LEDs sort of poke through the bottom. So I've put my cell phone case here on the bench, and I have that LED over the hole for the camera to give me a place where I can secure the PCB, so as I push down on it, I'm not this thing isn't bouncing around because it's on the LEDs and not the PCB. That's the theory anyways. We'll see how well this actually works. I haven't tried this particular approach before. I have a video on how to replace these things that I made a while ago. I should probably go and watch it. I need to really flood this, aren't I? There we go. And the LED is out. So now I want to clean the pads, get rid of all that excess solder. I'm going to use some solder wick here. And all I'm going to do is come in here, put the copper braid over it. The copper braid It has some flux in it. When you put heat to it next to some solder, the solder is going to be wicked into the copper braid and off the pad. Like so. And that tip there of solder wick looks a little saturated with solder, so just cut that off. And keep on wicking. There we go, clean pads. Easy peasy. So now the question is, what do I replace it with? I can go online, I can order common anode RGB LEDs, 5mm diameter, and I will have LEDs that would work in this, and it'd be fine. In fact, I have a pack of like 100. But, as seen in a previous video where I tried to replace a few of these LEDs, the color isn't quite right. So I would like to replace this with a similar LED. And what I have found is that the RGB LEDs inside holocrons are the same RGB LEDs used in the blades. So here's a piece of holocron. The holocron that this used to go to was used for experiments. It no longer functions. So these LEDs I kept because I knew that they matched the blade LEDs, and so what I'm going to have to do now is desolder this little LED right here, and this is going to become my replacement LED for the blade. My technique here is going to be pretty much the same as what I did to take it off the blade, take the RGB LED off the blade, which is I'm just going to flood a lot of solder here across all these connections. So I've got one big blob here that I can then come back and reheat while attempting to pull down on the actual LED itself, which is frackin' hot. Oh, there we go. Ow. Alright, the LED's cooled down. I'm going to straighten those leads out using these pliers that I have that have a flat edge to them with no crimp or anything. I bought these at a local hardware store. They were in like a clearance bin of just random junk. And I thought, oh, those look interesting. Having no idea what I would ever use them for. And they've actually been more useful than I would have ever imagined. Now, before I put that into the blade, I would like to make sure that it still works and that all the colors work. So, bring out the multimeter. And let's take a guess on where the common anode is. Blue is working. Green is working. Red is working. Excellent. I feel like the orientation is going to be something I need to mark. Okay, so the red is closest to me right now. Don't forget that. Sharpie. Little black Sharpie on one of the leads, just to remind me of the orientation. Okay, now I need to get myself set up to solder that onto the blade. The pads have been cleaned with some isopropyl alcohol. The leads on the RGB LED have been trimmed to fit. I'm going to put little flux on those pads there just to make life a little easier. And I'm going to tin one of the pads like so. And grab the LED, come in here and reflow the solder on that pad. Okay, that worked. So I held it in place and heated the lead, which was touching the pad with the solder on it. That melted the solder. The lead is now in place. Okay, let's test that LED to see if it's working. Red is working. Green is working. Blue is working when I touch the leads themselves. I'm actually going to come down here to the LED next to it. Okay, this is the one I changed, because when I do a diode test here, it's going to do a diode test for the whole bank essentially. So I want to make sure this lights up. If this lights up, then I know we've got a good solder connection. It lights up. It lights up. It lights up. Good solder connections. That LED has been replaced. Excellent. Time to put the blade back together and test it out. Time to do the reassembly. I've already fed the blade back into the foam here like so. I find just let the foam go all the way into the blade and then just keep pushing, and that will force the PCB into the foam, which can be a little bit of a tight fit. So I'm going to take the smaller piece that has a stem sticking out of it like so. That is the bottom. So with all these transistors facing up, that stem goes through the little hole there in the middle. And the other small piece goes right on top where this hole lines up with the hole in the middle, like so. And you just push that into the blade like so. It's okay, it's sticking out a little bit like that. It's a product of the foam, and I can do that. And now it almost stays in there. Let's go all the way. Perfect, there we go. Next, we need to put the outer shells on. I'm going to do the bottom outer shell first, which has the smaller of the two holes. You can tell just by looking at here and here and see which one is smaller. Put the smaller alignment pin in place. And then take the outer shell with the small alignment pin hole in it, line it up, and there we go. This piece here that has the contact pads, which is what connects to your lightsaber hilt, it has a little groove in it down in the bottom here. See that? And that is going to help it line it up with that little notch there, so you get the correct alignment when you're putting this back together. Just be aware of that. Big alignment pin. Top piece with the big alignment pin hole goes down. Now what I like to do, just to really confirm I've got alignment, is I stick my finger in here and I'll rotate it, and it will click into place once it's aligned correctly. So that way I know this piece is always aligned correctly, because if it's not going to make contact with the lightsaber hilt and your blade won't work. Now it's just a matter of screwing everything in, assuming that the screws behave, which they don't usually. I'll come back and finish tightening that up in a minute. I just want to get all the screws somewhat in before I tighten everything up. Good. 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 All right, blade is back together. It is time to test, and I'm going to remove that piece of electrical tape because it will work, and we don't have to worry about identifying where the bad LED was. Okay, here we go. And no dark spots. Well, you can see dark spots in between where the LEDs are, but the big dark spot, which was around here somewhere, is now gone. The blade has been fixed. We'll just cycle through a few more colors. What's interesting is now that that part is fixed, I am seeing a darker green here. I think you're seeing that in the camera. And then there's a darker green down here, which I think you can sort of see in the camera. Those are about where that's about the location of where those opaque LEDs were. So I wonder if that is the problem there. It's very weird that they would have a couple of LEDs in there that weren't quite the same. My guess is when they were being manufactured, the manufacturer probably had clear LEDs and opaque LEDs, or frosted, or whatever they call, and they probably just get all dumped into a couple of different bins, and if somebody's handling them and a couple drop into the wrong bin by mistake, you might wind up with a couple in your blade like I did. But it doesn't impact performance, it might create a slightly different color area, or a darker or lighter area. But yep, everything looked good. That blade is repaired. That is how you troubleshoot and repair a dead pixel, we'll call them, in a lightsaber blade.